Welcome to Canada. This is QGrooves. So Ivan, can you tell me, what is QGrooves?
QGroov is an app that lets you listen to qubits, the basic units of quantum computing. QGroov takes those abstract blocks, building blocks of quantum computing, something that's feasible to people, sounds and music. So you're literally listening to qubits.
How does it do that?
So what we do is we take the vector representation of qubits, take their amplitudes, and make those amplitudes into waves, and we make music with those waves. So people can listen to their quantum circuits and hear their quantum algorithms.
What are the advantages of doing this?
One of the big challenges of teaching the next generation of computer scientists that are going to use quantum computing is getting them to visualize that. It is very hard because it's an abstract concept, it's hard to visualize. So what we do is we make into sounds so you can literally understand the states, see the different pitches, and when you have the circuit, you can listen to the transformations. So when you have an algorithm, you can see the waves travel, listen to them, and notice the patterns, and we hope that will make understanding those algorithms more accessible to people.
So this is our graphic user interface for QGrooves. It was built with HTML5 and Phaser 3, and it allows the user to drag these quantum circuit components into this grid here, and they can arrange it any way they wish. And once they're finished, what they can do is they click the submit button here, and when they submit it, it will get sent to the back end to be processed and stored in MongoDB, and essentially this will create an audio file where they can hear their quantum circuit and rather than just see it.
After being processed in the backend by SonicPi and Qiskit, our data gets back to us, and what we have is a representation of the circuit and the audio. So, for each of the barriers on our quantum circuit, which represents the steps of an algorithm, in this case we have Groover's algorithm for search, we calculate the sound of the state of the system in that state, and we mix it. So, for example, in the beginning, as you heard, we have a mix of all the waves, so we have all the sounds being played, but at the end, we have the pitches that are the answer for the Groover's search problem. So as you can see, there are two nodes that are higher than others. It represents the answer to your problem. So the idea for software is to help people visualize those steps of the algorithms by listening to them.
This is SonicPi, the backbone of our sound engine, and it will be playing the quantum Fourier transform.